What up? What up? What up? I don't know why I keep doing this intro like this today. We're gonna look at locating absolute extrema here. So we're gonna say f is a continuous function, and it's on a closed and bounded interval. Okay. If it's on a closed and bounded interval, and there's a continuous function, we will have an absolute max and an absolute min somewhere in it. And it will occur at either endpoints or at critical points. Okay? Endpoints or critical points. So what we're going to do, and remember, this is assuming f of x is continuous and it's defined on a closed interval. And I'm using a and b just to, that way it helps with the instructions later on. Step one, you want to find all the critical points. Take the derivative, set it equal to 0 or undefined, and find where they're at. At least all the x values. Let me change the way I worded that. Critical values. Critical points will do right here. So we find all the critical values, then we evaluate f of x at all critical values to find the critical points. Then we are going to take a look at we'll also do the endpoints. Okay? So let's say we got some wavy function like this. We need to evaluate it here, 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 and here. Step 2 has us doing the ones in green. Step 3 has us doing it there and there. There we go. That's cool. And then, so once we have all these critical points, and they're like a point, a coordinate, we'll figure out where the largest y value is and where the smallest y value is. That's our absolute max and min. And my pro tip is make a list. It's easier to keep track of shit. Don't just have it floating all over your fucking page. Don't be lazy. Make a list somewhere so it's easier to figure out, because if you don't do it, you're gonna go like you're gonna spend like minutes figuring it out. Don't be lazy. Not on this. It's worth doing. I recommend math laziness a lot in math, but not here. Sometimes doing more is better in the long term. So we are going to look at our first example. F of x is negative x squared plus 4x minus 3. We're going to be on the closed interval from 1 to 4. So step 1, take the derivative. The derivative is negative 2x plus 4. Is that undefined anywhere? No. So we'll set it equal to 0 to find our critical points. We have a critical point at x equals 2. Next, we want to evaluate f of x at all critical values. So we're going to do that real quick. Critical value right there. So step 2, we plug in 2 into our function. Into that bad boy. If I do, and make sure, this is really important. Students do this all the time and it's wrong. Negative x squared is negative x squared, not negative x squared. Okay? So when you plug it in, the reason why I emphasize this is when you plug it in, notice my negative sign is on the outside. If it's not on the outside, you square it and it goes away and you screw it up. So this is -4, and this is +8, which would give us +4 minus 3 is 1. So I've got the 0.21. This was my pro tip. Pro tip, pro tip being done right there. Step 3, my endpoints are 1 and 4, so I'm going to do f of 1 and f of 4. When you plug and chug those, you will get 1, 0, and 4, -3. This one is the left endpoint. This is the right endpoint. I didn't graph these because I want you to know that you don't, oh wait, you don't need to graph it to see that it's true. This process works. Finally, we look on the list. I got these values right here. The largest one is the 1. So I got largest y value is 1. I have an absolute max of 1 at x equals 2. My smallest value is -3. So I have an absolute min of -3 at x equals 4. That's how we do it. I think this might be the last example right here. So hit pause and try to figure out where the absolute max and min is for you. We've got f of x equals x squared minus 4 square root of x over the interval 0 to 4. Pause the video, work it out, see what you got. All right, I'll assume you did. I took the derivative. I get 2x minus 4. This is, don't forget, like square root of x is x to the 1/2. So when you take the derivative, you get that. 1/2 x to the -1/2. Okay, so I got 2x minus 2 over square root of x. What I did to get to the next line is I multiplied this by square root of x over square root of x. Okay? And when you do that, we can combine and make a fraction, and we get this. That's our f prime of x. It's undefined when the bottom equals 0. So square root of x equals 0. You square both sides, you get 0. Then we want to do the top. I set the top equal to 0. I divided by 2. And I got x to the 3/2 minus 1 equals 0. And I moved the 1 to the other side. And then I raise both sides to the 2/3 power. And I get x equals 1. These two things are my critical values. They're not the points yet. They're just the critical values because I don't have a y coordinate there yet. We'll do that on step 2. We find the y coordinate on step 2. F of 0, when you plug it in, you just get 0. That's also happened to be the left endpoint. Okay. And then when I do f of 1, I've got 1 squared minus 4 is -3. So I got the point 1, -3. I've already done the left endpoint, so we still need to do the right endpoint. So step 3, check the other endpoint. F of 4, 4 squared minus 4 root 4. This is 4 times 2, which is 8. 16 minus 8 is 8. So the right endpoint is 4, 8. Step 4, we're looking for the largest value. The largest value is right there. So we have an absolute max of 8 at x equals 4. And our smallest y value is -3. So I have an absolute min of -3 at x equals 1. And that's what we're doing in this section, folks. That's all we got. I'll see you in class. Peace.